Hi. In this series, we're going to explore probability and how we use it either consciously or unconsciously every day to make decisions. We'll then look at probability models that can be set up mathematically. But before we can use the model to solve any probability problems, we need to know some probability terms and notation. To give you an idea of what we mean by a probability term, let's listen in on a conversation between Refilwe and Gerard. Every time they use a probability term, it'll come up on the screen, so watch out for them.
Gee, I'm worried about these exams. There's not enough time to get through all of this. How much have you done?
I'm not even trying to get through it all. I'm just doing the bits that Mr. Kanya said were important.
I guess I wasn't really listening.
Well, whenever he said, "Now this is very important, so pay attention," I ticked it off in my book. I reckon those are probably the chapters he's going to focus on in the exam. I figure if I just learn those chapters really well, I should know enough to pass. Want to see which chapters they were?
Yeah, please.
Every day we make decisions, and many of those decisions are based on something called probability. In the conversation we just saw, Refilwe decided what to study using what she thinks will probably come up in the exam. In this lesson, we will review what you should already know about probability. By the end of this lesson, you should be able to explain what probability is, define a possible outcome, a favorable outcome, and a trial, and you should be able to describe and use the probability scale. Let's watch another scene and listen carefully to the words used. You might want to have pen and paper ready so you can write down any words you hear which you think are about probability. Watch out for anything that sounds like the learners are considering their chances. Ready? Let's watch.
So guys, what did you think about this morning's maths test?
There's no way I passed. No sane person could possibly know what was going on.
I think I've got a 50-50 chance of passing. Last week's test was much worse though. I'm worried about Zola's party tonight. Do you think Lebu's gonna be there?
Probably. I mean, Lebu is Zola's cousin after all.
I've never seen her miss a party, so she's more likely to be there than not to be there.
Then it's pretty certain I'll be there. How about you?
I'll try, but after getting home late last weekend, there's not much chance my dad will let me go out.
Did you notice how loaded that conversation was with probability words? You may even have used some of those terms yourselves. Let's see if you picked up all the probability terms in the conversation.
So guys, what did you think about this morning's maths test?
There's no way I passed. No sane person could possibly know what was going on.
I think I've got a 50-50 chance of passing. Last week's test was much worse though. I'm worried about Zola's party tonight. Do you think Lebu's gonna be there?
Probably. I mean, Lebu is Zola's cousin after all.
I've never seen her miss a party, so she's more likely to be there than not to be there.
Then it's pretty certain I'll be there. How about you?
I'll try, but after getting home late last weekend, there's not much chance my dad will let me go out.
All those words and phrases are probability terms because they all have to do with the likelihood that something will happen. So we can define probability as the measurement of the likelihood of an event. Every day we estimate chances and make decisions based on these estimates. Most of the time we don't work out the exact probability of something happening. We make a rough guess. So the language we use is vague and not accurate. For example, when Gerard said that there wasn't much chance that he would be able to go to the party, how little chance did he mean? One person's idea of not much chance is very often different to another person's idea of what that means. So although we use probability in our thinking and communication, we're not usually specific enough or careful enough to be mathematically accurate. In some situations, more accurate probability calculations can help us make decisions about important issues. In fact, there are people who have made careers out of doing those sums for us. For example, you may look out the window and see no clouds, but the weather forecast predicts an 80% chance of rain in the afternoon. So you take your raincoat anyway. The weather forecast uses calculations based on the patterns observed over time. So we can use probability to predict more accurately what the chances of rain are. Gerard Refilwe and MacGyver did a fun investigation to answer a probability-related question they came up with. We're going to use that investigation as a basis for our review of the basic terms in probability. So let's see what they came up with.
Our teacher said something in class today that got me thinking. She was pinning a notice and dropped the drawing pin on the floor. When Gerard went to pick it up, she told him not to worry.
Yeah, she said you always find them later stuck to your shoe and used another one.
So that got me thinking. If it's true that every time you drop a drawing pin, it gets stuck in someone's shoe, that must mean it always lands with the point up.
Well, if it landed point down, it couldn't get stuck on the shoe, could it?
Anyway, I thought surely a drawing pin doesn't always land with the point upwards, or does it? Or maybe a drawing pin is designed so that the flat part is heavier and it always lands that way.
Well, let's investigate it.
Good idea.
But how?
Why don't you drop a whole box full of drawing pins and see how each one lands? We would need to drop them in different ways and from different heights to give the drawing pin lots of chances to land in different ways.
As well as dropping them, we could flick them.
We can hold them point upwards and drop them, as well as holding them pinned down when we drop them.
Let's stop there a minute and use what they've said so far to review some probability terms. First of all, what do they want to find out? They want to find out if a drawing pin always lands point up when you drop it. Now, when you drop a drawing pin, there are actually only two ways in which it can land. Point up like this, or with a point facing down like this, so it actually falls onto its side slightly. Each of these two ways of landing is called a possible outcome. In this case, the drawing pin landing point up is called the favorable outcome because this is the outcome they want to find out about. To find out how often the favorable outcome occurs, they planned an experiment in which they actually dropped drawing pins. Each time they dropped a drawing pin to see what happens, they are testing for the possible outcome. Each of these tests is called a trial. Now let's see what actually happened with the investigation.
I started off by dropping pins from a desktop.
Just to be different, I got as high as possible to drop mine. And I decided to flick mine, like I was flipping a coin.
You also threw a whole handful on the floor.
It gave us a lot of different results. Very quickly though, didn't it?
Not really. We spent ages trying to find the last two.
And where did we find them? Stuck in your shoe.
Well, we dropped 100 drawing pins in total, in all sorts of different ways. And as we suspected, they definitely do not fall point upwards every time. In fact, look at this.
Yes, the number of drawing pins that landed up is almost the same as the number of drawing pins that landed pointing down.
So we can say that a drawing pin has much chance of landing point up as it does point down.
In other words, we definitely can't say that a drawing pin always falls point upwards.
That's an interesting example of probability. Now I want to show it to you on a probability scale. The probability scale is a number line from 0 to 1 on which we can plot the probability of any event happening. If something is guaranteed to happen, we say it's certain and it has a probability value of 1. But if something is guaranteed not to happen, we say it is impossible and it has a probability value of 0. The space on the number line in between 0 and 1 is for any event that is likely to happen or unlikely to happen. If two things are equally likely to happen, then their probability value must be exactly halfway between 0 and 1, which is at 0,5 or a half. Our 3 learners conducted 100 trials with drawing pins. Their conclusion was that a drawing pin has an equally likely chance of landing point up as it does of landing point down. So we can show that the chance of the pin landing point up is represented here at 0,5 on the probability scale. Do you remember the statement from MacGyver earlier on?
I think I've got a 50-50 chance of passing.
In this case, the 50-50 refers to percent. If something is guaranteed to happen, then it has a 100% chance of happening. So if two events both have an equally likely chance of happening, then each one has a 50% chance of happening, since 50% is half of 100%. Let's go back and look at Gerard, Refilwe and MacGyver's conversation again and see if we can place some of their other statements on the probability scale.
Do you think Lebu's going to be there?
Probably. I mean, Lebu is Zola's cousin after all.
Refilwe is saying it is closer to certain than impossible that Lebu will be at the party.
I'll try, but after getting home late last weekend, there's not much chance my dad will let me go out.
Gerard's words suggest that the possibility of being allowed to go to the party has a value closer to 0 or impossible than to 1 or certain. In the lessons to come, we'll use the probability scale a bit more, but for now, let's summarize what we've covered in this lesson. We started by noticing that our language reflects how much probability we use in thinking and decision making, but the words themselves are not specific enough to be used in mathematics. We can calculate more accurate probabilities in a mathematical way using numbers, percentages, or fractions. This use of probability can be defined as a numerical measure of how likely it is that something will happen. When we do a probability experiment to see how many times a certain outcome will occur, we call each test in the experiment a trial. All the possible results that come out of any trial we conduct are called the possible outcomes. And a specific result we want to find out is called a favorable outcome. Finally, all probabilities can be plotted on a probability scale. This is a number line from 0 to 1. Just to see how much probability creeps into your life, walk around for the next week with a small notepad and a pencil in your pocket or bag. Listen to the things people say and look at a print material such as magazines, newspaper articles, ads, and whenever you hear or read a phrase which you think is related to probability, make a note of it. Remember, this exercise doesn't only have to be done in class. In fact, it will be more interesting if you do it at home or at the shops or wherever. Then, in your maths notebook, draw a large probability scale, decide where the things you noted go on the scale, whether they go on 1, on 0, or somewhere in between, and place each of your statements on the scale. And at the end of the week, you could swap books with some friends and see if you agree with each other's work. Join us next time when we will definitely be looking at more probabilities.